Hello, hi everyone. Uh, Nice to be here in Indonesia. So today I will talk about something like shedding the VMware layer, a migration to bare metal infra. So before we start, I have something for you. So life since 2024 has changed quite a lot. So you're spending more money on VMware renewal than food, rent, and all those things combined. And the biggest problem is things are not certain yet. VMware is changing their licensing model again and again and again. So maybe you will spend all your money over there. So a bit about me. I'm Hrittik and I'm flying all the way from India, and this is my first time with OpenInfra Indonesia. I'm a CNCF ambassador, mostly active in the CNCF community, and I work as a platform advocate at Loft Labs. So today we will go through a bit of story. So how many of you know this logo? Yeah, couple of hands. So yeah, this is Kubernetes, and Kubernetes acts as a layer for application delivery in a lot of organizations right now. It's an open source CNCF project, helps you self-healing and all those capabilities, as well as it's a key to modern and cloud native infra right now. So if you break down Kubernetes, there are two parts of it. There is a control plane and then there is nodes. So there is orchestration components, deployment components, and all the other components, including your storage. So if you look at the diagram to be more simple, so you have a node pool, you have an API server. API server is like the brain, which all the components, and node pools are your VMs. So nodes are the physical or the virtual machines where your actual workload runs. And they are responsible for running the actual workload from your machine, like the containerized application. And what are nodes? So nodes can be your bare metal VM, cloud instances, anything. So those are basically a VM or a compute unit where your things are running. And each node has a couple of services to ensure that whenever your workload is running, everything is smooth and all the required resources are there, including scheduling and all those things. And the good part about Kubernetes is it's a distributed orchestration system. So your nodes can be in a different geolocation than your control plane, and all of those nodes can be everywhere around the world. So you see how distributed this is. So when we talk about nodes and VMs and hypervisors, I want to go back to understand how VMware is fitting into the picture. So nodes are basically machines like your servers, and generally whenever you use nodes, it is like the virtual machines. They emulate all your compute, storage, networking layer. And then there is the hypervisor layer. So it's very hard for cloud providers or everyone to provide specific hardware for a specific team, like the dedicated pool. So you share a pool across your different VMs. So they offer a strong isolations for each of your nodes and reduce the overhead. But how does that work actually? So if we go to simple diagrams and all those things, so you will have a hardware, you will have your hypervisor layer, and then you will have a couple of VMs on top of that. So each VMs can be served independently or served together, whatever you require. But this is the simplest one. Then as things grew, as the complexities were more, there were a couple of different type of hypervisors. One was the one which sits on your operating system, which is the type 2, and then one was the initial type of hypervisor. With the initial type of hypervisor, you had different VMs which had different OSs inside of it. With type 2, it's faster, it's more optimized, and you will have similar like your local VMs which you are running on your machine. But the problem is with all those layers, you are combining the complexity and the cost as well, and reducing how efficient your infra is at the bottom. So then there came something more like containers. So containers were a new thing 10 years back, where 10, 20 years back, where containers came as a lightweight solution, which ran on your virtual machines, local machines everywhere. And what it provided was a way more lightweight and faster approach, where you had a capability to run your applications and know the whole operating system stack. So if we go to the diagram to understand what it is happening, so you had your hardware, which is your VMs or your local machine. Then you had your operating system. And then there was a container engine like Docker or something like that. The container engine was responsible for a significant amount of isolation between different containers. And your different containers were running different application logic. Some were running the front end, some were running the back end, some were running a specific microservice in combination of services, and then you can connect the networking and all those things. So containers with hypervisor. So traditionally, Kubernetes is run on VM, and each of the VMs has their operating system and all those things. So if we look at it, so you have a containerization layer, you have a virtualization layer, and both of them are stacked up. So when the stack up happens, there is a question like why we need a VM hypervisor? Why not go the bare metal route where you are just running containers on your host? So there are some problems with that, but we will go into that. But first is the advantages. So when you run containers on the bare metal, you get lightweight, more performance, and you have to remove all the increasing complexity. And the resource utilization is far better. But the problems are there as well. And the problems like if you have different tenants which require strict isolation, that is not the most optimal way. And then the other problem is noisy neighbors. So for example, you have a couple of teams using the same hardware and the same stack. Then there might be a possibility that a team is changing something which will impact the other team, and different versions can also be impacted. So generally, if we compare the container and the VM layer, in the virtual machine layer, you have the hypervisor over the hardware, and in the container layer, you have it over the operating system. With type 2 hypervisor, that is also possible, but when we combine them, there is two hypervisor kind of layer. So the question is, if you want to remove the hypervisor layer for virtual machines, so that you'll remove the virtualization costs from VMware and all those things, how about you go about virtualization actually and tenant isolation? Because whenever we think about tenants, isolation is very important, not just because of the user experience, but because of compliance and all other reasons. So how do you do that? So here I want to introduce something called vCluster. So what vCluster does it? So it creates virtual Kubernetes clusters on top of your host cluster. As we will dive deeper in some time. So the advantage of this is you create Kubernetes as your base hypervisor. With that, you can have strong multi-tenancy, and each of your teams can have a Kubernetes cluster of their own where they are running their workloads. So if we dive deeper into this on the diagram, so what we do is like you bring a host cluster, and host cluster is running on top of your hardware, and that is your sole hypervisor. And whenever there is a requirement for a team to have an environment, what you do is you create a virtual cluster for them. And the virtual cluster is there and helps them to go and run their workloads in complete isolation with different virtual cluster. So as you remember about containers, the containers were there to help you run isolated environments and all those things. This is a way ahead of that, where you are creating virtual Kubernetes clusters instead of a normal hypervised virtual machine. And the good part is like, with a lot of hypervisors, you need to get access to the host cluster to access the virtual machines. But with this, you can share your virtual clusters across different teams. If you go dive deeper, the concept I'm proposing is like, whenever you use your bare metals, you can just install Kubernetes and treat it as your new hypervisor. So the problem with normal hypervisor is geolocation restrictions. So when it comes to Kubernetes, you can create a couple of bare metal node pools, and then Kubernetes can span across all those of the node pools, creating an abstraction for your infra. But When you do that, you treat Kubernetes as the base layer and your hypervisors, VMs, wherever which was there, you replace them. So if you want to look it in a diagrammatically way, so you have physical servers ranging in different geolocations in different data centers and region, and you have a lot of VMs running over there. And each VMs has K8s clusters combined together because everyone is moving towards Kubernetes as we grow. And the problem is like with a lot of physical servers, there is a lot of complexity to manage the underlying infra. So with vCluster, what you can do is you can combine all those and you can have a dedicated cluster for your shared hardware. So you don't need VMs for provisioning because it's more fast and cost effective. And if we look at the diagram, so you combine all of your physical servers with help of a shared node pool. And whenever there is a requirement for your node pool running applications, you deploy a virtual cluster, which is a certified Kubernetes distro on top of that. With that, what you get is more isolation, more CRD syncs, and all those things. So when we talk about the benefits, so there is a couple of them which I want to reiterate. So the first one is complete isolations for your team and workload. So if we go back to this diagram, so there you see there is two virtual cluster. One is NS1, NS2. So whatever is happening inside one of the virtual cluster, it is completely isolated with the other one with help of the virtual cluster API server. So you get the raw performance of your host in bare metal while you are getting isolation. Coming back. Next is you can add resource quota policies per vCluster. So if you want a team, for example, to use a certain amount of resources from your entire node pool, which is combined, you can do that. And then the other advantages, like, for example, if you're requiring faster provisioning and delete times, and where is this use case popular? Like for your CI/CD pipeline. So suppose you are using a CI/CD pipeline with a ingress controller and ingress and a lot of custom resources that requires time for you to install. So the traditional workflow is like you have a shared node with a lot of CI pipelines running over there, and you deploy containers and all those things as required. But with virtual clusters, you remove all those overlaid and have a host cluster which has a couple of things installed already. And whenever you create a virtual pipeline for your CI/CD, what you can do is you can sync all those host cluster resources like your Argo CD, your ingress controller, and all those things. And then your CI pipeline can consume that. So it doesn't need to wait for all those installation to happen, as well as it can streamline all of those things. And lastly, it also removes VM sprawl and all those things while reducing the requirement for your licensing cost. Next is, so I talked about a lot of things and a lot of numbers and a lot of things, but is it even real world use case? Like, do people really remove all the VMware they have created and all the technical that they have? One of the recent use cases we have is from Aussie Broadband. So where they use the open source vCluster tool to remove all of their virtual machines into a shared host. And whenever their team was requiring any deployments or pipelines or anything, they were creating a virtual cluster. So the numbers says that they were 99% faster cluster provisioning because you don't need to wait for a cloud provider to deploy and get the virtualization layer done, deploy a control plane and all those things. Faster deployment, if you are deploying clusters fast, you are deploying your infra fast, then you are deploying your application fast as well. And which also translates to saving on cost, not just the licensing cost, but as well as the cost of developer. So developers are one of the most expensive resources in your company. And if you are saving their time by improving and automating the infra they are using, you're saving a huge amount of cost in developer productivity as well. So productive developers focus on more important areas in the company instead of just focusing on how things are not working. And that is what you are saving 2.4 thousand hours of dev time per year, which the developers can focus on building new areas inside the organization. So what is the strategic benefit of bare metal Kubernetes? So as we discussed that having bare metal is having more performance, but this is not just CPU performance. So first you remove the operational and licensing cost because there is no hypervisor to be taken care of. But then you increase the resource efficiency. So as you are accessing the hardware directly, so you are more efficient without sharding the hardware. Last is, as we are moving to more and more and more AI workloads, everyone wants GPU. But GPU is costly, and you can share it across different tenants with MPS and all those things, and time sharing. But those are not optimal always. Because with time sharing, there is a stack of things you have already done, so that is not as secure as that. So having access to bare metal GPUs is also helpful because as you can isolate the CPU, memory, and all those things, you can do the same with GPU as well when you're doing bare metal Kubernetes with virtual clusters. Focusing on the most important thing. So whenever you go and talk to your company about migration and all those things to a modern infra, it's just like playing with fire because of the cost. But what leaders today should understand is there is not the cost of migration, but the cost of improvement as well. So the first cost you save is the licensing cost altogether because you're not spending to get VMware licenses anymore. Then you consolidate your hardware together. So there is more higher utilization. Like to understand this statement, suppose there are 10 teams and each of the teams are using the hardware 70% for their virtual machine. Then you have 30% utilization left across all those teams. So when you combine the teams together and deploy 30% less hardware, you get the same amount of utilization because you are combining all of those hardware together to form a more bigger node pool. And again, there is less maintenance and fewer moving parts because you are not dealing with a lot of regions and hardwares. Last is, it's just not about the cost, it is about something more. So when a lot of efforts goes inside an organization in modernization, and modernization doesn't mean just building a newer UI or newer app. It sometimes means something more deeper, as there is more different type of security and hardware requirements. Removing and moving towards Kubernetes on bare metal is kind of growing. There is a combination of OpenInfra and CNCF right now, with the CTO of CNCF joining positions in OpenInfra. So what we are seeing is Kubernetes is kind of being more widely adopted. And as there is requirement for more technologies, more GPU sharing, more stacking, having the latest tools in your arsenal is the way to improve the developer productivity as well as how you are building your companies. The biggest thing is like rolling out a cluster is fast. It removes all the burden which we have previously accumulated. So that approach is always helpful. And the core part about this talk I wanted to share is like, now the workloads as we are enhancing in different areas don't just require CPU, they also require GPU. And GPU sharing, as I talked, is hard, isolation is complicated, and whenever you do it, it's kind of linked to 1:1 ratio. But as same as you are doing CPU sharing with vCluster, there is a simple approach where you are using Run AI, Kubeflow, Volcano, all those scheduling layers to create a GPU pool which you can share across your tenants as well. So with the similar approach to moving to bare metal, you're getting CPU isolation as well as GPU isolation together. So if I talk about the final thoughts, so whenever you talk about the VMware layer, so eliminating that helps you unlock efficiency, speed, and cost savings. And tools like vCluster, which has garnered around 10,000 GitHub stars, and it's a very popular open source project, helps you to form and go more multi-tenant way. And the thing and the biggest concern about all of the teams which I have talked about is that migration is a big task. But again, migration is a helpful task because you are investing in the future. It's a long process with a lot of layers to be talked through and all those things. But when you go to the route of going bare metal, where you are orchestrating and making sure the tenants are different and all, you're focusing on your infrastructure agility and investing in the future. Last but not least, if you have a lot of questions or any questions, and if you want to join the vCluster community, where we talk about bare metal infrastructure, the AI, ML workloads, and all those things, this is a Slack link which you can follow. So I will wait for a couple of seconds for you to scan. And if you want to connect with me, I'm here during the event if you have any questions. So you can always ask me, or you can connect with me on socials. So it will be nice knowing you all. And sure, I'll wait a second over here as well. Yeah. And thank you so much for having me here. It was nice being in the stage and knowing the OpenInfra Indonesia community. I'm here all day, so if you have any question, feel free to ask me and collect your vCluster stickers from me. Thank you so much.
Because we still have more time, we will be open question for about 10 minutes. Is there anyone who want to ask?
I think
There's anyone to ask something? No? Just ask your hand. Oh, there's one. There's any question?
I think we can give them a break for 5 minutes so that they are refreshed for the next session.
Okay.
Thank you so much, everyone. It was great being here.